Today we're going to be talking about Lesson 1.2, relationships between sets of rational numbers, and how we can describe relationships between sets of rational numbers. A rational number is any number that can be written as a fraction. And when we're talking about classifying rational numbers, we are talking about certain sets of numbers. So a group of items is called a set. I want you all to fill in your notes with me. Everything I write, you write. And as a quick reminder, if you have any questions during this instruction, be sure you write a little question off to the side in the margin. A Venn diagram uses intersecting circles to show relationships among sets of numbers or things. So hopefully you all are familiar with Venn diagrams, and all this is doing is explaining that the smaller circle is also a set of the larger circles. So that means that all whole numbers are integers, all integers are rational. So the smaller circles belong to the set of the larger circles. So we're going to go through and write these terms out in a definition just so that I could be sure that you know exactly what we're talking about. Rational numbers, I want you to write, I had said before that it's any number that could be written as a fraction, but we always say if you can write a number as a ratio in the terms A over B, where B does not equal 0, then it's a rational number. So you have to be able to write the number as a fraction, and then it would be rational. Okay? An integer is any number on the number line including 0. And you all know that whole numbers are counting numbers. I want you to write any number we can count to starting at 0. That means that we start at 0 and count up, which means all whole numbers also must be positive. Okay, in example 1, oh, sorry about that. You can't really see what I wrote. Okay, there you go. Example 1, they want us to classify each of these examples, naming the set or sets to which it belongs. So some of these might have more than one answer. So let's look at these. A gives us the example of number 37. Well, we're going to start with the largest circle on the Venn diagram, rational. Is 37 a rational number? Yes, because I could write 37 as a fraction by putting it over 1. So we are going to list 37 as being rational. And now we're going to check if any of the smaller circles could also be listed. How about an integer? In integers, any number on the number line. So 37 is a whole number. And remember that all whole numbers are integers. So yes, we are going to also list that it is an integer. How about a whole number? Yes, we can start at 0 and count to 37, so we are also going to list that it is a whole number. Okay, now I want us to look at example B, which is negative 56/12. And we're going to check out of those sets in the Venn diagram, which one can we list? Well, think about this. Negative 56.12, the correct way to read that is negative 56 and 12 hundredths. Okay, you have to remember your decimal place value. Well, in order to be rational, it has to be able to be written as a fraction. If you were to write this as a fraction, negative 56 and 12 hundredths. Okay, you should remember from elementary school that this is a mixed number. Well, I can change this mixed number to a improper fraction. Okay, I'm not sure how you learned, but here at Hudson Bend we always say use Texas. And so using Texas, you would always multiply first. Okay, follow your order of operations. Negative 56 times 100 would be negative 5600. And then you have to add the numerator. So 5,600 plus 12 would give us negative 5,612, and the denominator stays the same. So I changed my mixed number to an improper fraction. Well, doesn't that look like the form a over b? Yes. So is negative 56 and 12/100ths a rational number? Indeed it is. Is it an integer? No, because it has digits behind the decimal that are not 0. And of course, it's not a whole number because it's negative. Remember, you have to start at 0 and count up. So rational would be the only set we could list on that line. Let's move on to example C, which is negative 98. Is negative 98 a rational number? Yes, because it is an integer, and all integers are rational. So I just said, yes, it's an integer. It's on the number line. It's a negative number. It has an opposite, so it is an integer. Is it a whole number? It is not a whole number because remember, it's negative, and whole numbers can only be positive. What about a fraction? What about D, 7/8? Well, if you think about, is it rational? Is it already in the form a over b? Yes, so we would list it is indeed rational. It's not an integer because it's not a whole number. It's not on the number line as a whole number or its opposite. It's kind of a fraction of a whole number. Well, not kind of, it is. It's a fraction of a whole number. So it's not an integer and it's not a whole number. So rational would be the only set we could list for that one. Okay, well, guess what? Now that you have had some examples that we have done together, now notice that your notes say your turn. So now it's your turn. I need you guys to pause the video. Did you pause the video? I'm watching you. Pause the video. Okay, so once you've worked these out, number 1 says -8. They want you to list what it could be. You should have listed that it's an integer and that it is rational. Number 2, you should have just put rational. Remember that it cannot be an integer because it has non-zero digits behind the decimal, and it's not a whole number because it's negative, and it's not a whole number, it has a decimal. Number 3 is rational because it could be written in the form a over b, but it cannot be an integer because it's not a whole number, so obviously it's not a whole number. And number 4 is all 3. It's a whole number, we can count to it. It is an integer because it's on the number line, and it's rational because we can put it in the form a over b by putting 3 over 1. Okay, we are moving on to the second page of our notes. Up at the top, we are understanding sets and subsets of rational numbers. So when one set is entirely contained in another set, we say the first set is a subset of the second set. You can use the Venn diagram to decide whether or not a given set of numbers is a subset of another set. Okay, so all integers are rational numbers. They want you to tell whether that given statement is true or false, and it also says explain your reasoning. So, are all integers rational numbers? Okay, from the notes that we just saw, you should say that this is true. And you can say that all integers are rational numbers because integers are whole numbers and can be written as a fraction, or you could put as a over b. Okay, what about the statement they give you in B? All integers are whole numbers. That is also true. All integers, no, that is a big false, silly machine. I had to read it again. All integers are whole numbers. Always read more than once. So it's false because in a number line, we have positives and their opposites. We have negatives. Well, remember, negatives cannot be whole numbers because you can't start at 0 and count up and get a negative number. So we have to say false because it's negative. Okay, and here we are at another, it's your turn to kind of process what we have just been taught. So I need you guys to pause the video, and you know who's going to make sure that you paused it and did it yourself. That's right. Okay, so for number 6, let's see if you guys got it right. Tell whether the statement, some rational numbers are integers, is true or false, and explain your choice. So again, it's asking for you to explain. So we want to say that that is true. Some rational numbers are integers, and you could say true because some integers are positive. Think about your number line. And in order to be a whole number, has to be positive. Some are not because obviously some are negative, but you don't have to write all that, okay, as long as you can explain why they are. Okay, number 7, describe a real-world situation that is best described by the set of rational numbers. A set of rational numbers, well, that could be a lot of things. It could be a list of fractions, it could be a list of integers, it could be a list of whole numbers. So they just want you to come up with where in the real world do you see rational numbers. Well, how about if we had a list of, I should put a complete sentence. Always try to write a complete sentence. A list of integers in a set of temperatures in a, I should have put, let's put recorded in a science experiment. So if you were recording a bunch of temperatures of something, you would probably have some negative temperatures, some positive temperatures, maybe 0 degrees. So that could be a real-world example of when you're seeing a set of integers. In the next section, it's asking you to identify sets for real numbers. So now they're giving you a real-world situation and asking you to identify the situation or the set that would best describe the situation. So even though some of these situations would have more than one answer, it's asking for the best answer. So I want you to think about the number of dollar bills in a person's wallet. Think about dollar bills, $1 bills, $5 bills, $10 bills, $20 bills. What kind of numbers are those? What's the best way to describe those numbers? Absolutely, if you were thinking whole numbers, you are correct. So we would say whole numbers because $1, $2, $5, etc. are all positive numbers. How about this golfing example? It's a leaderboard of different golf scores. And if you guys look at the column that has the scores in it, you see that there's -5, -2, -1, 0, and a +1. Well, which set that we've talked about today would best describe those numbers? And you should be thinking integers, because You could say there are, I know my paper's running off the, let me move it. Okay, and because there are positives, I'm just going to put the symbols, I'm running out of room, positives, negatives, and 0. And all of those can be found on the number line. So that is our lesson for today, and if you have any questions, jot them down somewhere on the margins of your notes and we will talk about them tomorrow.